So, this is all about creating Bluetooth-based digital badge for Europe's biggest Node.js conference. We also did an app, but I won't be talking about the app. I'm mostly talking about the badge. So, for those of you who don't know, who don't come from a kind of a hardware background, there's been a culture actually going well back beyond 2006 of doing digital badges instead of cardboard badges or paper badges at events. The most famous is DEF CON, which is the big hacker conference. That's one from 2006. I think it was one of the original ones they did. They have got more and more complex as time has gone on. At DEF CON and SuperCon, which is a Hackaday conference, it's effectively a competition now. Individuals come with their own badges that they've designed and sell them to other attendees. And they're all fantastic. They're a bit complicated though. Particularly the DEF CON ones, there's usually a whole like crypto thing you have to solve and all of that. And they also tend to be quite large and quite heavy. So if you look at the SuperCon one, that's from literally a couple of months ago. I mean, that has a couple of AA batteries hanging off it. It has a full QWERTY keyboard. It's running BASIC. I think it runs CPM for the old people in the room. Like they went fully retro with it, but I mean it's a fabulous badge. But we're doing NodeConf, so NodeConf is about Node and JavaScript. So last year we decided we'd do a digital badge, and this is it. I have one here for the hexagon, and this was just incredibly exciting for us to do. So basically, it's running a small little Bluetooth module here. I'm going to get the name wrong. NRF85, one of those anyway. Nordic Semiconductor. This is the type of thing you'd have inside a Fitbit or whatever. It runs Bluetooth low energy. But what's amazing about it is you can run JavaScript on this directly. So the Espruino project is JavaScript running on low power microcontrollers, which is what this is. So we worked with Gordon of Espruino fame, and we did all of these badges. So when people arrived into NodeConf 2017, they were a bit shocked not to get a paper badge. They got a piece of electronics. That you could not just software hack, but you could hardware hack as well. As I said, everybody loved it. The only flaw I think or the only mistake we made was we over-focused on hardware last year. And fundamentally, NodeConf is a software conference. We had a whole hardware line, almost nobody used it, boiling hot soldering irons and so on, people were slightly afraid of. So this year we said, well, we're doing another badge. We'll base it on Espruino again. As I said, Espruino it's JavaScript, it runs on these very low powered devices. The project itself, it's an open source project, anybody can contribute to it, and it's funded really by these boards. So going back to the original one, which is top left there, the original Espruino, up to Pixel, which was last year's device. Pixel actually, Gordon, who does Espruino, he took what we learned from this and he created his own device called Pixel. And in a nice iterative way, when we decided to do the 2018 badge, we based it on Pixel. That was the idea we wanted to do. You don't have to read all of that. It's lots and lots of text, basically saying, take this badge, make it better, and focus more on software, focus more on how it looks and how it feels and the overall sort of, I'm going to call it emotional response to the thing. This is quite, harsh and quite basic in terms of that. Make it USB chargeable, obviously lots of LEDs because everything needs RGB LEDs, that's a rule. Rechargeable, if you can see on this older one, it runs on a button battery. And have some fun, so stick on an accelerometer so you can detect that you're doing this and so on. And also not make it Wi-Fi. A lot of people ask us why we don't do Wi-Fi in these things. It's because of power. If this thing had Wi-Fi on it, it'd just burn through the battery in 15 minutes. So what we said was, well, we make it optional. So if somebody really wants to, they can stick Wi-Fi on this year's badge and stick a big battery on it and everybody's happy. Fundamentally, the main feature of the badge is to show a person's name. So that's the top request for the badge is it needs to show their name. But we wanted to do a lot with software. So things like use Bluetooth LE, so all of these badges broadcast that they exist, and kind of use those broadcasts to kind of do fun things, which I'm going to show you now as we go through. Use that accelerometer to do claps and so on, receive messages, receive alerts, send information out to the temperature sensor on the badge as well, so send the temperature people are doing, and just have a bit of fun with it. So those were sort of the requirements we started with, and that's what we created, which is this NodeConf EU 2018 digital badge. which is pretty beautiful, it has to be said. And that's it booting up. Normally it would have your name there, so as you can see, people walked in, there's Alva there. People walked into registration and there was 280 badges there, each one with a different name on it. We had a little glitch at the start. The guys who did the app did a little test and sent an alert, which we didn't know was coming, so 280 badges started buzzing at exactly the same time, which was great fun. I'll just quickly show you just in terms of visuals here, because it is quite nice. Here we go. So we can do various things with backlighting on the screen and so on. So we have a couple of different zones here, then we have lights going up and down and so on. And it's just nice. It feels nice, it looks nice, the design on it's beautiful. So it really kind of, you know, appeals to people at a really basic level of, I really like this as a thing, as a thing I can have on me. But in terms of what it did, Antoine, one of our designers, put this together at a very high level. Basically, 280 odd people wandering around with these on. We had 20 Raspberry Pis scattered throughout the conference, scanning for the information the badges were throwing out. Importantly, I didn't mention this at the start, opt out on all of this for privacy reasons. So when you got the badge, the first thing it said is, do you want to do this? There's a clock on it, so one of the things the Raspberry Pis were doing was sending out a clock signal so you could have the time. And one person complained that when they opted out of all the Bluetooth, the clock didn't work. Yeah, that's how technology actually works. If you're going to opt out, you're not going to get the clock. So Pis, 20 Pis, scanning everything, but also the Pis back-ending then into Azure. First port of call was IoT Hub. So IoT Hub was basically everything in and out on the system was IoT Hub. We had a back-end then running in AKS. I'll show you some more details on this, which was to do with the app. We would then monitor stuff in that, including alerts, and then send them out via IoT Hub to the badge. We had a nice conference display, which I'm going to show you in a second, which gave some nice overviews. We had a control panel, which allowed me to control everything and see what was going on. So for example, at one point, it looked like the Pis had crashed. It was just the Wi-Fi had gone down. So as always, it's a conference, it has to happen, it's a rule. So there's, as I said, the badge. This is what we've done post-event. We've written a little bit of code to turn them into very nice desktop clocks that are quite accurate, in fact, and we've done some personalized ones down the bottom. It has T-Rex, of course, that's a given. It has Flappy Bird, which is also a given. So they're the messy ones. But it actually has a real compass, so if you were lost in a hotel, you could use the compass to, I don't know. Pretend you're American and it's to the west. Where's west? But also, Gordon, who designed the badges, but he also did the firmware on the badges as well. We gave him the information as to where the Raspberry Pis were, in which room. So there was actually a live tracker here. You could actually open this thing and it would have a dot showing roughly in which room you were, if you're really lost and you couldn't actually tell what room you're in. And various other things, backlight, Bluetooth connectable, and a few other things that I can't remember. I'll talk more on that now in a minute. In terms of Azure, we use so much of Azure. We were told we kind of use more Azure than anybody else out there. We're using Azure Kubernetes Service, so AKS, for basically the app backend and a few web apps, which I'll be showing you in a second. IoT Hub, as I said, was the core, but there was lots more. We had functional apps for monitoring things, for filtering things. We had Stream Analytics, we had, I'll list them all off. Cosmos DB, we persisted everything. So I have some interesting stats on actually what we did persist in a second. Power BI, we did some early stuff with Power BI, but it wasn't in the final product. Databricks, we only started on last week, and that was very exciting, so I'll show you that now in a second. And mostly the developers use VS Code, and we use the IoT Toolkit for that, because actually, if you use the Azure IoT Toolkit in VS Code, you can tap into IoT Hub and actually see the messages going back and forward. Very quickly on that, the data flows, just to give you a sense, the badge wakes up for 10 seconds every minute, checks around, sees it getting any messages, broadcasts some data out. We had 31 bytes to play with, so anybody who comes from a JavaScript background, not 31 megabytes, not 31 kilobytes. We had 31 bytes to fit everything into, so yeah, it was a challenge. So as you can see, our JSON was quite limited. T for temperature, C for collapse. That's what it was sent out. RSSI is basically a power signal, so that's some of the location stuff we did. Basically, the pies would say, the power I'm seeing to that is about this, therefore I'm seeing it as being closer than that pie is seeing it, that sort of stuff. Onto the Raspberry Pis. Being a Node meetup, we finally got to Node. The Raspberry Pis are all running Node. The Noble library is a Bluetooth LE library. Brilliant piece of software. So you can basically write Bluetooth applications on Raspberry Pis, or it runs on Mac and Windows as well, in Node for, in the case of Noble, for basically scanning and pulling stuff in. So the Noble library was used to grab all this stuff from the badges. And then we use the Azure SDK to send that stuff up onto Azure. But interestingly, we only discovered after we'd written the code, the Azure SDK is based on MQTT.js, because this is all MQTT under the hood, so very low bandwidth messaging. Turns out MQTT.js was written by Matteo Collina, who works for NearForm. So it turns out, yeah, and Michael Dawson from IBM, one of the Node guys in IBM, did an article yesterday. He was pointing out that was one of the libraries that's used by all of the major vendors. So Amazon, Google, and Microsoft are all using voice going, MQTT.js, so written by us, so we were kind of dog fooding, we didn't even know it. And then Azure IoT Hub. In the other direction, as I said, the app backend was based on CouchDB. We had some functional apps that were just checking that for any changes in the schedule, firing those changes out, they get to the Raspberry Pis. The Raspberry Pis had 31 bytes to then send out now and next information, send out alerts, send out the time and so on, and the badges would then pick that up. Very, very quickly, the beautiful thing about Espruino is JavaScript on a microcontroller. You're not messing around with low-level C. That's all you need to do in Espruino to broadcast temperature and collapse. That's the entire thing. And most of that's comments. So it's very, very, very simple. That's very quickly the overall architecture. Badges, Pis, Hub, and then event up to our control panel, Stream Analytics, Azure Functions, lots and lots and lots of Azure, as I said. Raspberry Pis, really, really classy looking, I think you'll agree. That's my own personal dotted duct tape that I got in Aldi. So basically, we get to the hotel. I've obviously been there before to check things out. We had 20 Raspberry Pis to scatter around. The most efficient thing to do was actually to take the Pi to its own power supply and just stick it on the wall like that. And that's what we did. Had to kind of reconfigure about 20 of them on the day, but it worked unbelievably well. And I have some stuff I'm writing up around. These are $35 computers. So 20 $35 computers, plus a bunch of relatively inexpensive badges, and this infinitely scalable backend gave us just an incredible system. I mean, it's shocking what we achieved with very little. When you think about traditional industrial IoT, this thing worked, as I said, it worked seamlessly until the Wi-Fi went down for an hour. And other than that, it was flawless. It was amazing. But this is the stat. 1.24 million MQTT messages from 20 $35 computers and 280 badges. It blew my mind when I realized this. We had an initial outage on Monday because we hit the first tier 400,000 messages a day limit on Azure IoT Hub, so we had to configure a second hub. It just was stunning to us that you would be generating that amount of data with just no drama, like literally no drama. There was very little oversight from me. The only change I had to make over the 4 days was moving some of the Pis further up the walls because bodies were getting in the way. That was literally it. And these are the alerts, as I said, now and next up the top. Mr. Montoya was there on day one, I think. And the alerts would cause the entire badge. So one thing we had on the badge, we had 2 little buzzers there down the bottom, so the whole badge would vibrate. And actually this, obviously, we use the accelerometer to turn it around. We point it the other way around. And the badge would flash red. The point around that was the app was doing the alerts as well. But our thought process was, well, people's phones buzz all the time, and you ignore it a lot of the time. What we made sure of with the badges was it only buzzed very, very, very rarely. So lunch, you know, the buses are leaving, that kind of thing, and it worked really, really well. This is the control panel. It's a bit rough there, and it's not the full one, but basically, when everything was running, there was basically 20 pies. I could see exactly which ones were appeared to be live or not, what messages they were sending out, what alerts they were sending out. The original plan was to basically control all of them from here, using tmux, basically SSH into the 20 pies. When we got there, we discovered SSH was disabled in the hotel network, which is a slight problem, but actually didn't end up being a problem at all in the end. It just, because everything actually just literally worked. So this, we had a giant screen, and this is one of the web apps we built. So this was the heat map and the clapometer. So this was live data. So basically those badges were streaming to the pies were streaming to IoT Hub. IoT Hub was going to like Stream Analytics and so on, persisting into Cosmos DB. Pulling out all this data, crunching it, and showing basically, in terms of heat map, not the actual temperature, but where the people were as the day progressed. And the clapometer was really a bit of fun because it was just using the accelerometer. It was more to do with kind of movement than clapping, but it actually worked in the sense of, you'll see now in a minute, it correlated very strongly to when people were clapping. We originally thought, oh, we'll send people like a score of how much people clapped at their talks. No, that's just no. It was a fun idea, but we didn't do it. But yeah, you can see spikes there. So that would have been at the start of the first day. I do want to show you this video. So we only got this working this morning. So this is. I do have a slide in it. This is 1.24 million rows of data in Cosmos DB replayed. So you can see how things went. And I've cranked up the speed on this a little bit so you're not sitting here for the whole time. Registration on the first day. People in and out. McCurdy was the main place where most of the thing happened. Pre-assembly was where you went to get your coffee. The lounge is where you hung out. Clapping happening on the right as the events were happening. And that's it for basically the 3.5 days of what was going on. So that's where we think this is just top fun, to be honest. But it just shows if you can get relevant, useful information, all of that is actually available to you. Back to, so that's the control panel. Get rid of that because it's not showing you anything. That's actually that's NodeConf EU Live, so that's the current control panel. There's no actual Raspberry Pis there, but the app is actually still live, so we can do it. Oh, this is the one I quickly wanted to talk about. As I said last week, we said, okay, we want to try and do some we originally said the original spec for this was we want to do stuff with the data, but we didn't actually define what the stuff would be. So that happened post-event. At Venus, who did a lot of the code for the system, particularly the Raspberry Pi code and a lot of the other code on Azure, along with Ron, said, okay, I'll have a look at this Azure data, which turns out to be really, really interesting. So it's Apache Spark as a service. So you basically press a button and boom, you've got an entire Apache Spark instance. All the storage done, all the nodes done. We were pretty staggered. If I talked about the Rust Evangelism Task Force, this is the Scala Evangelism Task Force. Just in terms of sample code, we found some good sample code for crunching data down using Spark. Venus doesn't know Scala, but he was able to figure it out. And ran this query. It took about 15 minutes from the query and all the data. It then spat out a bunch of files which we were then able to access in a web app. And I was going to show you a video, but I'm actually going to show you the live thing because I'm that brave. So this is a pivot table he built with pivottable.js that takes all that data out of Apache Spark and shows you a couple of different things, badges, claps, and temperature. But you can actually see we have all the various rooms that we had. Some of these rooms had 4 Raspberry Pis, some had 1, most of them had at least 2. And it shows basically the density of badges in the different rooms as time goes by. That is Sunday evening when everybody registered at the hotel check-in and was near the hotel bar. Another privacy thing we did is we only ran this during basically working hours, so it was not running for obvious reasons at any other time. We also made 15, I think it was 15, the minimum number of people we showed in any one area, just again for privacy reasons. And that all worked very well. And then it is very, very interesting, possibly not to you, but to us as event organizers, showing the flow of people as the day progressed. The peak of people, so the peak of people on day 1 was 9 AM, which was the launch of the actual event, not on day 2. Or day 3 for that matter. Tail off of people, obviously on the last day, you see the people tailing off as they some people tend to leave early at events and so on. So loads of mining we can do for ourselves that in no way impinges on people's privacy. So for example, when we handed out the badges, there was no correlation of badge to person. We randomly picked up a badge, flashed it in and gave it to them. So we didn't know who had what badge in terms of the Bluetooth MAC address. And then when the data hit the pies, the first thing they did was hash the MAC address. So all of the data in Azure is completely obfuscated in terms of who those people were. So all of this is aggregate information that we can use rather than to use the GDPR thing, personally identifiable information. So that's fun. Similarly, as I said, we did the same for collapse. Temperature, I don't know what that temperature sensor was that accurate on the badges. I think it was more giving the temperature of the person, because it was like the sensor's there. So yeah. But again, trends. So one thing we're working on the live replay of the temperature at the minute. We should have that working tomorrow. Because one of the days the pre-lounge or the lounge area was incredibly cold because the doors were open, and then they cranked up the heat and you could see the temperature went through the roof. So it's kind of seeing things like that, again, learnings for us, for the hotel, for the conference center and so on, just things you can do with all of this. I think I'm nearly done. It's open source, or it soon will be. The badge itself, so Espruino, the interpreter, always has been open source. The design of the hardware, totally open source already on that repo there. The code that runs on the pies, the code that runs everywhere in Azure, that will all be open source probably next week. So just keep an eye out on the NearForm blog. It's all there to use, and I probably won't be next week. I think there's a little bit more work to do to generify, is that a word? The PWA code, so the app code, before we release that. Just nobody wants a NodeConf EU branded app. There's not much you can do with that, so we're making it pretty generic. So if anybody wants to go and run with this stuff and do events, we know of people are already asking for more badges to be made for their own events, and it's open source. They can do that. They can knock themselves out. We're delighted that they do it. And I think there's lots to be learned from the Azure side of things, not just on the Raspberry Pis, but basically, other than that little snippet of Scala I showed you, everything was Node. All the functional apps were Node. All of that was done in Node. So there was some, Cosmos query language stuff, I think, on Cosmos DB, but other than that, yeah. So that was it. We're delighted with it. It worked really well, and the only problem we have now is how do we do a better one next year? I'm really struggling. So if you have any ideas, let me know afterwards. Thanks.